Hello everyone, welcome to today's class. The topic that we are going to see today is Android sensors. So what is Android sensors? Now, the most Android powered devices have built-in sensors that measure motion, orientation and various environmental conditions. These sensors are capable of providing raw data with high precision and accuracy and are useful if you want to monitor three-dimensional device movement or positioning, okay? Or say if you want to monitor changes in your environment near a device. Say for example, a game might track readings from a device's gravity sensor to infer complex user gestures and motions such as tilt, shake, rotation, or swing. Likewise, a weather application might use a device's temperature sensor and humidity sensor to calculate and report the dew point. Or you can have a travel application that might use the geomagnetic field sensor and accelerometer to report a compass bearing. So let us move on to the types of sensor. So there are mainly three types of sensor. They are the motion sensors, then you have the environmental sensors, and last but not least is the position sensors. So for your motion sensors, these sensors basically measure the acceleration forces and rotational forces along the three axes, and the three axes are your x, y, and z axis, right? So this category includes accelerometers, gravity sensors, gyroscopes, and rotational vector sensors. Then you have the environmental sensors. So this sensors measures various environmental parameters such as your ambient air temperature and pressure, illumination, and humidity. So this category basically includes barometers, photometers, and thermometers. Now lastly, for your position sensors, this sensors essentially measures the physical position of a device, right? So this category includes orientation sensors and magnetometers, okay? Moving on to the Android sensor framework. So you can access sensors available on the device and acquire raw sensor data by using the Android sensor framework, okay? Now this sensor framework provides several classes, okay, and interfaces that will help you perform a wide variety of sensor related tasks, okay? So for example, we can use this sensor framework to do, say, determine which sensors are available on a device, okay? So we can locate what are the sensors that we want to use, say, for our application. If they are available on our device or not, we can check it through the Android sensor framework. Again, we can determine an individual sensor's capabilities, okay, such as like its maximum range, power, requirements, and resolution, okay? So if what is the maximum resolution for a sensor, or what is the power requirements for a sensor, we can determine that through our Android sensor framework. Next, we have the acquiring raw sensor data and define the minimum rate at which you can acquire sensor data, okay? So this can also be done through your Android sensor framework. And lastly, we have the sensor event, right? And we can register and unregister the sensor event listeners through our Android sensor framework. So these are some of the things that can be done via our Android sensor framework. Now let us move on to the sensor hardware software based types, okay? The Android sensor framework lets you access many types of sensors. They can be either hardware based or software based, okay? So if it's hardware based, they are physical components which are built into a handset or a tablet device. They derive their data by directly measuring specific environmental properties such as, you can say, acceleration or the geomagnetic field strength that is around us, or the angular change in, say, while you change your mobile angle from one position to the other. Now software based, on the other hand, are not physical devices, although they might mimic the hardware based sensors. Now these software based sensors derive their data from one or more of the hardware based sensors, and are sometimes they are called virtual sensors or your synthetic sensors, right? Now the linear acceleration sensor and the gravity sensor are examples of your software based sensors, because these two sensors, they basically derive their data from more than one, okay, hardware based sensors. That is why they are known as synthetic or virtual sensors. Now, few Android powered devices have every type of sensor. So this is something that you need to keep in your mind. All the Android powered devices will not have each and every type of sensor. A device, on the other hand, can have more than one sensor of a given type. Say for example, a device can have two gravity sensors, each one having a different range. Okay, so these are the types of sensors that are supported by your Android platform. So you can visit the link that is provided in this line. Okay, just click on it and it will let you go to a link where all the types of sensors are provided. Now here in this chart, you can see some sensors are given that are basically supported by our Android platform. Then you have the type, okay, whether they are hardware or software type, basically their description, what they do, and the common uses where they're used for, okay, these sensors in our application. So let me give a preview of some of these sensors. Say for accelerometer, this is a hardware type, and it basically measures the acceleration force in meter per second square that is applied to a device on all three axes, such as your x, y, and z, including the force of gravity. And the common uses of this are motion detection, such as shake, tilt, etc. Okay, then you have a sensor which is type ambient temperature. This is also a hardware type sensor, and it measures the ambient room temperature in degree Celsius. Okay, and it is used for monitoring air temperatures. uh, Now we have the type gravity. Okay, so it can be a software based sensor, or it can be a hardware based sensor. Now it basically does the same thing as your accelerometer, which measures the force of gravity, okay, in meter per second square. Instead of the acceleration force, it measures the force of gravity, right? So here it basically measured the acceleration force, but for your gravity, it will measure the force of gravity that is applied to a device on all three axes, right, x, y, z, and it is also used for your motion detection. So then you can see you have the sensor type, which is gyroscope. It is also a hardware type sensor, and it measures the device's rate of rotation, okay, in radian per second around each of the three physical axes. So in this way, have a look at all of these sensor types, sensors, their types, their descriptions, and their common uses. Okay, then let us move on to the sensor framework classes. Now in the sensor framework classes, we can see there are four major classes. The first one being the sensor manager, second one sensor, third one sensor event, and the last one is sensor event listener. Okay, so your sensor manager, you can use this class to create an instance of the sensor service. Okay, now this class basically provides various methods for accessing and listing sensors, which we will see later on, for registering and unregistering sensor event listeners, also, which we will see later on, and it also acquires orientation information. Okay, other than this class also provides several sensor constants that are used to report sensor accuracy, set data acquisition rates, and calibrate sensors. Now moving on to sensor, so you can basically use this class to create an instance of the specific sensor. So basically using this sensor class, you can create objects of this sensor. Okay, now this class provides various methods that let you determine a sensor's capabilities, which we will see later on. Okay, now for sensor event, the system uses this class to create a sensor event object, which provides information about a sensor event. A sensor event object includes the following information. What are this information? It contains the raw sensor data, the type of sensor that generated the event, okay, the accuracy of the data, and the timestamp of the event, okay, the timing when it collected the data, okay, that will be there. Then we have the sensor event listener. So you can use this interface to create two callback methods, okay, that receive notifications, that is sensor events, when sensor values change or when sensor accuracy changes. We will also see sensor event listener later on in our slide. Moving on to identifying sensors. Okay, so the Android sensor framework provides several methods that make it easy for you to determine at runtimes which sensors are on a device. So if you want to determine what type of sensors you have in your Android device, or if you want to particularly identify a specific sensor type, then you can do that using the Android sensor framework SensorManager class. Okay, so to identify the sensors that are on your device, you first need to get a reference to the sensor service. To do this, you create an instance of the SensorManager class, okay, by calling the getSystemService method. And in this getSystemService method, you need to pass in the sensor service argument. So firstly, what we need to do, we need to create a SensorManager class object, right? So this is my SensorManager class object, and using this SensorManager class object, I have to get an instance of the getSystemService by passing in the sensor service as our argument, right? So in this way, basically we can create an instance of our SensorManager class. So this is by default that you have to do to create an instance of your SensorManager class. Now, if you want to get a listing of every sensor on a device, you can do so by calling the getSensorList method using the typeAll constant, okay, which for your SensorManager object. Okay, so what will be happening here? So if you want to get every sensor, so in my list here, I will be storing sensors, right? So this list will contain an array of sensors that are on my device, and this is named as device sensors, right? Now, using the SensorManager instance that I have declared earlier here, okay, I will use the getSensorList method, and in this method I will pass sensor.typeAll as an argument. So this will fetch me all the sensors that are in my device. Now, if you want to list all the sensors of a given type, okay, we can use another constant instead of typeAll, such as you can use type gyroscope, type linear acceleration, or type gravity. Okay, now you can also determine whether a specific type of sensor exists on a device or not, okay, and you can do that using the getDefaultSensor method, okay, and passing in the type constant for a specific sensor. So you can pass the type gyroscope, type linear acceleration, or type gravity, or any type specific sensor, okay. If a device has more than one sensor of a given type, one of the sensors must be designated as the default sensor. On the other hand, if a default sensor does not exist for a given type of sensor, the method call returns null, which means the device does not have that type of sensor. For example, the following code checks whether there is a magnetometer on a device or not. So since we have to get an instance of the SensorManager class, we do this by calling the getSystemService as I have shown before. Now you will use this SensorManager instance that you have declared and use the this getDefaultSensor, right, method. So you will use this getDefaultSensor method, and you will pass in the specific type of sensor, default sensor, that you want to fetch from your device. Okay, now if the result is not equals to null, that meaning that if this method returns you a default sensor, then it means it's a success, there is a magnetometer, okay, in your device. But if it goes to else, it means it's failed and there is no magnetometer. Now moving on to the sensor capabilities. These sensor capabilities can be retrieved from the sensor class. So there are various methods in sensor class to get the capabilities of a sensor. The first one being get minimum delay. Now this method, it returns the minimum time interval a sensor can use to sense data, and this is done in microseconds, right? So any sensor that returns a non-zero value like 1, 2, 3, which is non-zero, for the get minimum delay method, it is known as a streaming sensor. Now what are streaming sensors? So these streaming sensors sense data at regular intervals and were introduced in Android 2.3 API level 9, right? If a sensor returns 0 when you call the get minimum delay method, it means that your sensor is not a streaming sensor, because it reports data only when there is a change in the parameters it is sensing. Okay, now moving on to the get power method. Okay, so this method, it is used to obtain a sensor's power requirements, and it is done in microampere units. Then we have the get maximum range, which is a method to obtain maximum range of measurement, right? And then lastly we have the get resolution method, which is a method to obtain a sensor's resolution. So these are some of the sensor's capabilities that one can access through the sensor class. Now moving on to the sensor events. Okay, to monitor a raw sensor data, you need to implement two callback methods that are exposed through the sensor event listener interface. And these two callback methods are the on accuracy changed and on sensor changed. So firstly, sensor's accuracy changes, right? For the first case, this method will be invoked, on accuracy change. So this system invokes this on accuracy change method if a sensor's accuracy is changing, okay, and it provides you with a reference to the sensor object that changed and the new accuracy of the sensor, right? So if a sensor accuracy changes, then this method is basically invoked, and it will provide me a reference of the sensor object whose accuracy has changed and the value of the new accuracy for that sensor, right? So this accuracy is represented by the four status constants. So what are these four status constants? They are sensor status accuracy low, sensor status accuracy medium, sensor status accuracy high, or sensor status unreliable, right? Now, if a sensor is changed, if it reports a new value, in that case, the system invokes this on sensor changed method, okay, providing you with a sensor event object. Now, we already know for a sensor event object, it contains four vital information, okay, about the new sensor data. So what are this? It contains the accuracy of the data, okay, the particular sensor that generated the data, okay, the timestamp at which the data was generated, and lastly the new data that the sensor recorded. Okay, now this is a example code for your sensor event listener. Now here we have a public class sensor activity, which is a subclass of your activity class, right? And it basically implements the sensor event listener interface. Okay, so the sensor event listener class interface, as I have already mentioned, has two methods, which is the on accuracy changed and on sensor changed method, right? And so firstly, what we can see here, so it has a SensorManager class object, which is known as SensorManager. Then we are using mLight as our sensor, so it means that we will be using the light sensor. Now as you can see, I have called an instance of the SensorManager by here by getting the get system service, right? And the mLight is the SensorManager.get default sensor.type light. So in this mLight, the light sensor will be stored. Now as you can see, I have defined two methods, on accuracy change, which will have a reference of my sensor, that is the light sensor, okay, and it will have the accuracy that has been changed, the new accuracy, right? So this method will be only be invoked if the accuracy of my sensor that I'm using in this sensor event listener is changed. Okay, now for on sensor changed, this method will be invoked, okay, if the value of our sensor changes. Now here it will have a reference to our sensor event, okay, and the sensor event is named as event. Now we can do various changes in this. We can know the timestamp that when the data was generated, right? And then we can also know which particular sensor triggered this change, right? And we can basically manipulate its values. Now we have furthermore two methods which are necessary to observe here. One is the on resume method and the other is the on pause method. So on resume method, what we basically do is we can register a listener, okay, and in this register listener there are some parameters which we will see later on. Then we have the on pause method, which will basically unregister your listener. Okay, now you have to keep in mind that you must unregister listener. So this is a best practice to you. I mean, if you register a listener, then you must unregister a listener as well. Now as you can see here, there are four parameters. The first one is this, which means your sensor event listener. Okay, so basically this means that the class, that the interface class that we are in, right? So this interface class is your sensor event listener, okay, and mLight is your sensor, particular sensor, okay, that you want to register. And then you have your SensorManager instance dot sensor delay normal. Okay, so let us look into this aspect more. So the parameters in registering event listener, as I have already mentioned, is the sensor event listener that you're in. So this was previously written as this, right? Then you have the particular sensor and you have the data delay. which was previously it was sensor delay normal. So what is this data delay? This data delay or desampling rate controls the interval at which sensor events are sent to your application via the onSensor change callback method. So basically this onSensor change callback method is being called at a particular interval, right? Now what is this interval? So the default data delay is suitable for monitoring typical screen orientation changes, right? And uses a delay of 200,000 microseconds. So there can be some trivial actions like monitoring typical screen orientation that takes place while you are sensing data from your outside, right? So those pre-processing or those processing takes some time, and that time is set as 200,000 microseconds for your sensor delay normal. So at an interval of 200,000 microseconds, what will happen is this on basically this on sensor changed method callback will be receiving sensor events. Okay, so data will be, this on sensor changed method will be invoked at an interval of 200,000 microseconds, and this method will be receiving the sensor values, the data, the timestamps, right? Or the specific sensor that is triggering your or changing the values of the sensor, right? Now we can specify other data delays such as sensor delay gain, which is 2000 microsecond delay, sensor delay UI, which is 60,000 microseconds delay, or we have the sensor delay fastest, which is 0 microsecond delay. So as of Android 3 API level 11, you can also specify the delay as an absolute value in microseconds. Okay, so now the question begs, which delay should you select? Now you must remember the delay is set so that other background actions that are happening in our application can happen smoothly. So before receiving a sensor event, okay, you are receiving sensor events at an interval. So what happens between that interval? All the background actions are happening in that interval. So if you want to have a smooth transition of receiving your sensor events, then you need to complete those background actions as well. So that is why the time delay is kept at 200,000 microseconds, so that all the actions or changes that your application requires at that interval between that time is done, it is over with. Okay, so you need to keep in mind what application, which specific type of application you are making, so that the transition from one interval to another interval, when your sensor event will receive notification, so that that interval is set in such a way that your background activities are completed. Okay, so this question remains that which delay should you select. Okay, so this is an important question. I hope you can look further more into it, research it and find the answer. Now we have the sensor coordinate system. So in this coordinate system, the sensor framework uses a standard 3-axis coordinate system to express data values. So this 3-axis, as you can see, it is your x-axis, y-axis and the z-axis, right? So for most sensors, the coordinate system is defined relative to the device's screen, okay, when the device is held in its default orientation. Now when a device is held in its default orientation, the x-axis is horizontal, as I've already shown here. The y-axis is vertical and points up. The z-axis on the other hand points outside of the screen face, right? So in this system, coordinates behind this z have negative values. So this coordinate system is used by the following sensors, like the acceleration sensor, the gravity sensor, you have the gyroscope or the linear acceleration sensor, geomagnetic field sensor as well. Now moving on to the last bit, which is our best practices for using sensors. So we need to gather sensor data in the foreground. Okay, we cannot keep collecting data in the background. Okay, then it will cause a lot of wastage in power, drainage in battery power, right? So always we need to gather sensor data in the foreground, so so our user are basically aware of these things happening, right? Then we need to unregister sensor listeners. We have to test this sensor with our Android emulator, right? So let me show this to you. So basically this is our Android emulator and we are basically moving it and checking, right, how the virtual sensors are working. So we need to also test the sensors with our Android emulator, right? As you can see here. Then moving on, we have to we cannot block the on sensor change method, since this on sensor change method is invoked at an interval of 200,000 microseconds, right? So we cannot block this sensor change method. We need to keep this sensor change method in such a way so that it is running smoothly. We also need to avoid using deprecated methods or sensor types. We need to verify the sensors before we use them, and we need to choose the sensor delays carefully. So this will be all for today's class. Hopefully you have understood it all. Thank you.